Hello all, welcome to my YouTube channel Tech with Kemar. So the topic that we are going to talk about today is the DNS, the domain name system. It is a very fundamental part of the internet, and we can also say that the DNS is an internet phone book address. So basically DNS allow user to connect to any website using the domain name instead of the IP addresses. So if you belong to the IT industry, you have probably heard about this term so often, DNS. But if you are a complete beginner and you don't have any idea about the DNS, don't worry. We are going to talk about the DNS in this video and how does it work. So before digging into the more details, let's see what are the topics that we are going to cover in this video today. So starting with what is an IP address, what is DNS, how does DNS work, then different type of DNS server involved in the query, and last but not least, the architecture diagram of the DNS. So when you make a request from your browser, how does this request travel through the internet and various components to the actual website? So make sure you stick to the end of this video to find out these things. So let's jump into today's first topic, what is an IP address? So before starting the IP address, we should understand that what is an IP. So IP is an internet protocol, and in the internet protocol, it is a set of rules that is defined that how the packet is transferred over the internet. So in order to make this concept very easy to understand, let me give you an example about the post office that you have into your country, right? So if you want to send a postcard to anyone, there are two major things that you need to define. First is who is sending the postcard. In this case, maybe I'm sending the postcard. And the second, the to address, whom I'm sending to the postcard, where it should be delivered. So from and to. These are the two important pieces of information that you need to write on the postcard. So same way, IP protocol have the same thing on the packet. Packet is kind of a postcard you can consider. So whenever I want to go from my browser to the google.com, there are two things that is needed. Who am I on the internet and where I want to go on the internet. So that way, the IP address come into the picture. The IP address itself is a unique identifier on the internet that can identify who is who on the internet. So the IP address itself is assigned to all devices that are connected to the internet so far. So let's say that I'm working from my laptop and I type google.com, then my laptop have one unique IP addresses, and I want to go to the google.com, so the Google have their own unique IP addresses. So that way, when I send a request from my computer to the Google, the package, the postcard is sent on the internet, the IP protocol have two important information. First is my IP address, and second is the Google IP address. And then this package can easily travel from my browser or my laptop to the google.com. So no matter where I'm sitting, this two information is very much important and it is needed. So in the IP address, we have two kind of schemas. One is IPv4 and one is IPv6. We will talk about this IPv4 and IPv6 difference and what are those things in some another video. But so far you can remember that we have IPv4 and IPv6. You can see in the slide that the IPv4 and IPv6, how it look like. It will be really difficult to remember if you can see that 192.168.1.1, or if you talk about the IPv6, it is a hexadecimal representation of the same thing. But if you see, it is very, very difficult to remember. And for a person to remember all this IPv4 and IPv6 is a very, very tough task. The problem is that there are so many websites and applications on the internet, and everyone have their own unique IP addresses. We as a human, if I want to search the Google or Facebook or Instagram, or maybe I have to see some reels on the TikTok or somewhere. But in order to reach there, the Facebook or Instagram, I have to remember these IP addresses of their own. And that's how I can reach there. And remembering this IPv4 or IPv6 address is too much difficult and it is a nightmare. So this is the problem, and DNS solves this problem very, very efficiently. So yes, now we can go to the next topic. What is DNS? So the DNS is a domain name system, as I mentioned, and it is a phone book for the internet. Why we say that it is a phone book of the internet? Because the functionality of the DNS is the same as your contact book or phone book application you have on your smartphone. In your smartphone, you probably have so many friends and everyone have their own number, but you don't have to remember everyone's phone number, right? Because what you do is go to the phone book app and just add a new contact, name, and the phone number. So the same way DNS work with the internet. The internet have the domain, which is google.com or facebook.com or instagram.com, and the DNS also store the domain and the IP addresses. So it is like the phone number and the contact detail in your phone book, so that we can say that it is a phone book of the internet. So the main idea behind this is that when the DNS have all this entry on their server about the domain and IP, so that we don't have to remember about the IP addresses or IPv6 addresses. We have to remember just facebook.com, the domain name, or the google.com. So DNS let us allow connect to the website using the domain name instead of the IP addresses. And this is a really good understanding of the DNS. So the next topic is, how does DNS work? So far we have understanding that what does DNS do, or what is a DNS. So let's see about the application, or how does the DNS work behind the scene. So in order to understand this concept, let's say that DNS keep a table into their memory or in their storage system. So in that there is a two entry, one is the domain and one is the IP. So whenever you ask to the DNS that, hey, I want to reach or I want to go to the google.com, and the DNS will do is like, okay, where you want to go, google.com. He will check the google.com into the database quickly, and if they find this entry into the database, he will quickly return you the IP addresses. So now your browser directly connect to that IP addresses. So this way the DNS work behind the scene for any website that you visit. So now let's talk about the different kind of DNS server that are involved into this complete cycle, the question and answer thing. Like browser asks the question, or browser query the DNS server, and the DNS server responds to this query. So let's understand what are the different components. So far there is a 4 main component to understand the whole DNS thing. The first is DNS recursor, second is a root name server, third is a TLD, or we can say top level domain, and last the name server. So let's start with digging or understanding about the first one, the DNS recursor. So let's say that you went to a big library, a very big library, and there you have to find the book, maybe let's say the Atomic Habit from the James Clear. I like that book personally. So let's say that you want to find that book onto the library. So first you go to the library, and then the first thing you have to do is that you go to the librarian and ask that, hey, I want to find this book. Could you please help me locate that? So that is the first server, DNS recursor. You can consider that DNS recursor server as a librarian who will receive the query from your browser or your computer. And then in order to find this resources, or you can say the book on the library, it will make some additional request or search with the additional section. So that is the work of the DNS recursor. Okay, so now the librarian will take care of the further thing. You asked for some books, and the librarian will check the index. The index of the books, like the books may be started from Atomic Habit, will have the A section somewhere. So that is the index, not the actual location itself, but it can point to the specific rack where you can find this book. So that is the root name server. Root name server keeps the index of all the domains and where to find the specific domain on the internet. So the next step is the TLD name server. TLD name server stands for the top level domain. So once the librarian have the index that where it should start, then the librarian go to that specific index section, and then the task of the next DNS type server came in, that is the TLD, top level domain. We can say that the top level domain is kind of a specific rack on the internet, so that whenever you want to find google.com, then any part of the last of the domain, which is a .com, it is a specific rack, or let's say that wikipedia.org. So in this case, the .org is a rack, specific rack. So any domain you take, maybe wikipedia.org, google.com, or xyz.ai. So this .ai part is your TLD. So now you have the idea that which rack to find. So far we know that we go to the librarian, which is a DNS recursor server. Librarian, now we just wait there and the librarian will make the additional request. So DNS recursor will next check the index list, which is the root name server. Once you find the index, next step is to finding a specific rack so that the root name server, the DNS recursor will send the next query to the TLD server, the top level domain server. In this you have a specific rack where is this book is. And the last but not least, we have the authoritative name server. So each domain on the internet have their authoritative name server, or we can say NS server. For an example, Google, Wikipedia, Instagram, everywhere have their specific name server. So in the case of the library, we might have the specific name server for the author itself, James Clear, where he have many different kind of books. So now we reach to the specific point, starting from nothing to the specific points or section of the book area where we have all the books about the same author. So in this case, we have all the IP addresses about the google.com in the internet. So that is the authoritative name server. So as we have discussed into the previous slide, in this slide you can see that the browser is the topmost where it starts its query. So browsers send the query to the DNS recursor that, hey, I want to find the google.com. So now the DNS recursor is the main middleman who is taking care of all the requests that is coming from the browser itself. So we don't have to directly interact with the different kind of component, but everything will be taken care by the DNS recursor. So as a DNS recursor now, its first responsibility is to send the request to the root name server. It is an index as we discussed. Once we have something from the root name server that, hey, go to this .com rack section, then the response from the root name server go back to the DNS recursor. Now DNS recursor know that in which rack we have to find onto the TLD domain. So in the TLD side we have many different kind of the different rack, we can say that is .com, .org, .edu or .ai, but in this case we know that google.com is a .com, so we go to the .com TLD name server. So from .com TLD name server, the TLD server will return the specific authoritative name server, the specific section on the rack where all the Google query are remaining or all the domains is there. So from the second section, we again get back the response from the DNS recursor. And now the next step is DNS recursor will go to the authoritative name server, which is the google.com in our case. And if it is the .org TLD name server, then it will go to the Wikipedia org. So this is the diagram where we know that how these things work. So as I promised, we are going to see the architecture diagram of this whole DNS query process. So let's check this diagram. So it is very much easy to understand for you that what is going on behind the scene. So this is your browser, www.google.com, and the browser. The first request the browser send in order to connect to the google.com is this request. Like, where is the google.com? The request received to the DNS recursor side. And the first thing that DNS recursor sees is what is the domain that they are looking for, and then it will ask to the root name server that where is the .com, and for this the root name server reply with the tld.com location that, hey DNS recursor, if you are looking for the .com, go to this TLD. Then the DNS recursor will go and ask, hey, where is the google.com, to the top level TLD, which we got from the first step. And on the TLD side, they have many different server TLD, that is .com or .org, as I mentioned before. So in this TLD side, it will return that, hey, this is the Google name server, authoritative name server. Go there. And then the third step, DNS recursor will go to the authoritative name server section and ask, hey, where is the google.com? So here, this is the last destination for the DNS recursor, and the google.com name server will return the IP addresses that, hey, this is the IP addresses. Of course, this is not the correct IP, but just in order to make you understand how this will resolve the IP addresses. So once the DNS recursor have the IP addresses, it will go to the browser. Again, the DNS recursor will send the same request back to the browser, and then this request, the browser will go to the same IP addresses, and then it will finally reach to the google.com. So far this diagram make it very easy to understand that first step is DNS recursor, and then after the DNS recursor will take care of all the things from querying to root name server, TLD or the authoritative name server. The important point here to notice is that as you can see, the root name server have the waterfall kind of thing. They have all the connection toward the many things. So let's say that the domain name server, root name server have .com here, and this is the google.com authoritative name server. And if you have the facebook.com, then you probably have the another server, facebook.com, which is connected to this .com here. So that way it is, the structure is always like the root server and then more top level domain. And once the top level domain you reach, let's say google.com, then all the .com websites are under that. Or if you go to the org, then all the org website is under to that level. So it is kind of the waterfall thing to make this understand. Now the very important question here is that you have probably seen that it is quite a lot of things or quite a lot of query that you need to make just to reach to the one website. From here we can say that 1, 2, 3, 4 or 5 requests we need to send just in order to get the IP address of the google.com. Then the question is, isn't it too much time taking, or isn't it make your website slow? Like when I type google.com and if you have to query this many things to the internet, isn't this going to be very slow for me? So yeah, if you have to make this request all the time from your browser to this same way, then it is very costly. I mean, in terms of the network bandwidth and the time perspective, it is a very costly because it will take so much time just to get the IP address of the Google or any website every time if they have to go to this flow. So in order to fix this issue, we have the one most important concept here, which is the caching. And I think you probably know about caching, but caching is a temporary storage of very important information that we use quite often. So in this case, we have a caching on a different layer in this whole life cycle. So let's say that your browser, first step where the query begin, the google.com. So in that case, rather than browser making the first request to the DNS recursor, it will first check into the local cache that, hey, do we have any IP addresses recorded for the google.com? If you have the IP for the specific domain, then this query resolve here and no need to make any of this traversal. Okay, but what if we don't have this cache? So the second level cache is your OS, either Mac or Linux or Windows. The OS itself have their own cache for the DNS. So the browsers send the next request to the OS that, hey, do you have any cache for the google.com? If the OS said that yeah, then again it is resolved there. But if not, then the next request go to the DNS recursor. In most of the cases, the DNS recursor itself is your internet service provider or your ISP. So the thing is that even if your browser doesn't have the cache or your OS doesn't have the cache, but internet service provider is a kind of a big thing because many of the users are using the same internet provider, right? So let's say that if you are not querying or searching for the google.com, but some other user has probably made this query, then this google.com query cache is already presented in the DNS recursor. So when you don't have the cache in your browser or your OS, probably the DNS recursor have this cache into their cache memory. And most of the time when you open or request anything, your query will always resolve into the DNS recursor itself and don't have to travel all the way through. Because just imagine that every query, if they have to go to this root name or TLD, then it is so much network bandwidth or so much traffic for the server itself, and they cannot sustain or handle this many traffic. That's why we have built this mechanism, caching on each layer. So then after, the DNS recursor will either query, check into the local cache, or query to the next root name server. And once, let's say that we don't find on the ISP or the DNS recursor side, so in that case, this whole travel journey will happen. But in that case, once you have the response on the last step, then the DNS recursor will save the cache into their local system, same with the OS and the browser. So from the next subsequent request, you don't have to worry, or you don't have to travel all along this way. So that way it will make it very easy to load any website faster. So this is how the whole picture and behind the scenes work. So far we summarize all these things. We learn about the IP addresses. It is a unique identifier. How does DNS work, and what is DNS? It is a phone book of the internet. And we see how the different kind of component involved into making this simple query. And last, we check the architecture diagram of the complete picture, how this thing work. There are some of the other topics and important concept in the DNS, like TTL, or the different kind of DNS record, the type of the DNS record itself. Maybe we can cover this kind of topic in the next video. Let me know if you want to learn about those topics. I will try to make the video around that topic as well. For now, I think that's enough for this video. So thank you for watching this video. Thank you so much. And if you have any question or any query, feel free to add this comment on this video. And if you like this video, don't forget to hit the like and subscribe button to my YouTube channel. Thank you so much. I see you in the next video.